Good afternoon, good evening, or good morning, wherever you're joining us from today. My name's Sarah, and I am the Program and Event Manager at the Reactor in Sydney. Welcome to a Microsoft Reactor Sydney live stream event and another episode of our Devs Down Under series. Today, I'm excited to welcome back Akanksha Malik. So Akanksha is a Microsoft AI MVP, an international speaker, and a managing consultant at Atlas Consulting. At Altis, she is working with clients to help them solve problems by making more informed decisions with data. She is a firm believer in diversity and inclusion. She is also an avid advocate for the women in STEM and is currently the network director of Women Who Code Melbourne. She is also the current board member for the Global AI Community, a free platform that also connects AI enthusiasts to experts. So for today, we will be speaking for about 40 minutes with 10 minutes for questions. However, do send us your questions throughout in the Q&A and we'll try and answer as many as possible. And also at the conclusion, we'll share with you a link to our feedback survey. So if you have a chance to fill that out with the event code, that would be great. And we'll also share with you the link to our YouTube channel where the on-demand version will be available straight after today's session. But for now, I'll hand the floor over to Akanksha to begin. So thank you so much, and over to you.
Thank you for joining in. Thank you for joining in at your lunchtime, especially, which I feel like is possibly the most precious time of the day, to be honest. But I'm very excited to have you. I will probably stray away from going into full presenter mode just so I can kind of keep an eye on the stream and make sure it's actually working the way it's meant to work. So bear with me not having a full screen. Sarah has done an absolutely fabulous job of introducing me. So, I might skip over a little bit of this, but I am a Microsoft AI MVP. I love talking about machine learning and how it can help everyone around the world. And I'm also a managing consultant at I nearly just said Atlas too, but it's Altis Consulting. And if you are looking for anything to do with Azure Machine Learning Studio or any solutions around it, or anything we talk about today, feel free to reach out. We're more than happy to have these conversations. I'm really excited to have these conversations. So reach out, maybe I can help. So look, without that, let's dive straight in. Today's agenda is going to essentially be showing you how you can create a model with no code necessary at all. And based on that fact, kind of showing you how Azure Machine Learning is enabling various different skill levels across the board. This, again, kind of ties in with my whole, I guess, real interest in democratizing AI and kind of making it available for everyone. And it doesn't matter where you're coming from or the background, it's an accepting and welcoming platform for everyone there. So let's just have a quick look at what is going on in the world, like AI in the market. I think most people who are here today listening, it has become this big thing that everyone wants. Everyone wants it. Everyone wants it applied somewhere in their business. They want to be able to say they're using AI. It's just become this big buzzword where knowledge mining, AI systems, autonomous systems, like all these things people keep using, which is great. Like it's a great way forward. But with the demand for it, there's also quite a limitations along with the adoption that presents it. The people aspect of it. It's great wanting AI, but it's quite specialized as a skill, right? Like being able to implement models and understand the data and how do you actually code out solutions and how do you interact with data that's in a machine and put them all together and make them understand everything that's going on in terms of human logic. So the people aspect is quite a big one in this scenario where even if you do find the right person, there are so many different ways of doing everything at the moment, from languages to platforms to everything else that goes into creating a solution with AI. So it's great. You might be able to find a perfect person who knows how to use Python and fits in really well with your culture. But if they move on and the only other person you can find uses R, how does that all mesh? And how do you find the right person again moving forward down the line? So people, very big challenge at the moment, especially with everything in the current climate. Impossible, really. And the processes involved, I think, when you start thinking about the infrastructure you need for machine learning solutions, the kind of constant maintaining and the monitoring of them, managing it all is just such a big part of kind of day-to-day IT processes, right? Where when you think about machine learning, a big common theme that comes up is you need a lot of data, which great, it's available everywhere these days, but you also need a large compute power to manage all that data. which costs money. Not every business has the money ready to shell out for multiple different servers and compute powers to process all that data. And the last one is the actual technology and the lack of flexibility that can exist if you build an on-premises solution, or the security and the scaling. Okay, perfect. You've gotten the process down. You've got your servers ready. You've got your people who are going to build on top of that servers and use your data to manage it. But if you've only built out for, say, the last 5 years of data and you've fully vetted out the solution that you need and exactly how much compute you'll need, what happens 5 years down the line when you now need to process the last 10 years worth of data and you've now got so much more data to scale across for your solution? And how do you do that then? By having to buy more servers, or what do you do? How do you scale that up? All these kind of questions that play into it. So a lot of these challenges come in and can be really daunting to businesses. And Azure Machine Learning is essentially setting out to try and alleviate some of these as much as they can. Which brings me to democratizing AI. Essentially, I think I've mentioned it like 4 times already, but literally my favorite topic on to do with AI or machine learning. Every single day, we are generating so much data, whether it's our own data or something we're using. Anything we do just produces data at this stage because we live in such a technologically focused world. And I think my point behind that was, why should someone who's only ever been to college for 8 years and has done PhDs and really understands maths and how does a computer talk to itself, why are they the only people that can actually access that data and fully leverage that? Everyone should be able to leverage the data they're creating or need to be using on a daily basis. And that's essentially what the idea behind this is, to make everything available for most people and just make it a little bit more accessible. So with that, I'm going to dive into how Azure Machine Learning is actually providing a platform to be able to do this. So there's a few different aspects to it. Whether you're a machine learning expert or you're coming in with absolutely no coding experience, that's absolutely no problem. And the same goes for kind of, hey, do you understand how machine learning works? What are the pipelines? What does the model actually do? How do models work? Doesn't matter what scale you sit on at that end of things as well. They've kind of built out 3 different variations within it of how you can use the platform. So if you're someone who is a data scientist or a programmer and have been coding away for your whole life, and you fully understand the statistics and how you're going to build out different models and hyper-tune them and all the different things that can be involved with it, we've got notebooks and the SDKs, which are essentially a platform ready to go for you. What it'll do is it provides the compute power to essentially leverage all that behind the scenes, so you don't have to buy your own. You can have a very small and essentially you can actually do it from a tablet now. You can properly code from an iPad and create a machine learning model, just because the fact that the compute power, you can essentially borrow it from Azure. So that caters to that aspect of things where you're either an ML expert or a coding expert or both. You're good to go. It's ready for you to be there and make your own models as bespoke as you like. The complete opposite end of that is someone who's got no coding experience and no machine learning expertise either at the other end of it, but they do understand their data and they know that machine learning or even being able to predict different parts of it would be really helpful. And that is where AutoML sits in. So essentially what this is a completely no-code platform where you can pop your data in, use that as you go. I think it takes, we'll be going through a demo, but I think it takes about like 4 clicks altogether, like clicking a few different things altogether for them. And you've got a machine learning model that's being trained for you on your data, given the parameters you want around it. Absolutely, like it's probably one of my favorite things. It's one of those things where you don't need to recreate the wheel. All these different models have been created already. You can just try your data against all of them and it'll find the best one for your fit. And Designer is a product that kind of sits in the middle of the two. And essentially, this is a case where you don't need to code. It is a drag and drop solution, but you do need to understand how machine learning works. You need to understand that, hey, I've got data and I need to split the data and I need to clean it. And then I need to use this specific algorithm to be able to apply a model to it. All those aspects do come into it a little bit. So it does cater kind of all the different areas that you might need. And don't get me wrong, AutoML, as much as I've put it into the no code and no machine learning background, it's also used by data scientists. Like I've used that in a case of, I'll run my data through it very quickly, and it cuts down a lot of the pre-prep work that I might need to do as a data scientist. It makes your life so much easier, I think. Instead of trying out 15 models, it'll narrow it down to maybe 2 or 3, and I can just try and hyper tune those and make those a lot better as I go forward. So that was just to give you a quick idea of all the different parts we'll be talking about. What we are going to focus in the demo are going to be the automated ML and the designer aspects, obviously because this is all about zero code solutions today. So that's what we'll be talking about. I will be done with the slides in a minute or two. We'll be diving into live demos to show you how to actually do this all yourself. So what is my data? So we will be using data. We will be going and creating different models to create samples. So I've got two data sets that we're going to use. One is Airbnb. The world is starting to open up again, even though the internet isn't apparently. But hey, I mean, I'd like to start traveling again. And I've got a data set here, which has got data of Airbnb listings in New York. And maybe I want to be able to predict how much should I be paying for a specific apartment or a specific room in a place. What's the predicted price for something like that? And compared to the pricing that has been hosted on Airbnb, has that gone completely up in inflation? Who knows? But we can use the model to figure that out. And the other data set we're going to use is a used car data set. And that's all around essentially, how can I predict? It's the same kind of problem. How will I predict the price of a secondhand car based on different features that it has? How many miles has it driven? What kind of a car is it? How old is it? All those different features to be able to tell me, hey, this is probably a fair price for this car. And if we can do that, maybe I can then leverage that to buy a secondhand car with the right price and get the right fair pricing for it. So those are the two use cases we're going to be looking at, and we'll use one in Designer and one in Automated ML. So with that, let's dive into our demo. So I hope everything is still visible and nothing has dropped out on the Wi-Fi end of things, which I'm sure Sarah will jump in if that is the case. But for now, let's dive in to the home place. The Azure Machine Learning Studio, the Azure Home. This is where if you ever want to create anything, off you go, find your home portal. And the first thing we'll do is we want to create a machine learning. So we'll look up machine learning. And this is what the landing page for this looks like. I think one of the best parts of Azure is if you've used it a few times, like once or twice, you'll start noticing consistency around their UI. So if you've created any resources before, the process is very similar throughout the way. So if we're going to create machine learning workspace, all you really need is a subscription, a resource group, which essentially think of it as like a container box where anything you create for a specific project sits in that container box. And if you're kind of done with it and you've tested it out as much as you want and you want to get rid of it, you chuck out the whole box. It's the easiest way to delete all the things you create. So I can select a pre-existing one. I'll just pick one that I've created. And all you need to give it then is a name. So let's call this Reactor demo. And it'll pre-fill all the different things that also need attached to your service. So it needs a storage account where you can actually store your data or anything is running in the background. It needs access insights and key vaults, a few different things. You don't necessarily need to worry about them. It will create them all for you. There's no real kind of case for not creating them. It does need those to be able to function properly across the environment of Azure. And you just have to pick your region. It tends to pick whichever is closest to yourself. At least that's what I've found. But I would also just recommend picking one that's closest to yourself, or you might have some kind of limitations on where your data can be sitting. So if you're in Australia and you have to keep your data in Australia, there is a region that's available to you to be using. And that's essentially it. And you can kind of hit review and create, and it'll go and start deploying essentially for you a workspace ready to go. I won't do that because I've already created one, and I'm going to go back to that. Let's say okay. So once it has created it, this is kind of what it looks like. I'm just going to push this away. So this is what your landing page will look like. You've got all your details over here on the left-hand side in terms of figuring out what's happening or the back end of things. But what I really want to be able to do is launch directly into the studio. And this is what your Azure Machine Learning Studio looks like. And I see Sarah has popped back into the thing.
I have. We just had a couple of questions come through from Avril, I believe that's their name. They just said they went on and they weren't able to access the same web page you were on. And they said, should we be creating a virtual machine first?
What web page would that be? Sorry. So if you go into the portal, the Azure portal.azure.com, if that's down, I'm kind of questioning whether Azure is down fully. From there, you just need to create machine learning as a resource that we just went through, and you just hit create. that sets up the environment that you need. So this deployment does take a couple of minutes, if that might be where they're still waiting on the deployment part of it.
Okay, great. Well, let's see if that solves it. And if, Avril, you still have any questions, please do pop up in the comments section. If not, Akanksha, please carry on.
No problem. So this is the landing page of the studio, kind of where everything sits. Like I talked about already, the notebooks, automated ML, and Designer are right over here. Everything you kind of need is over on the left-hand side panel. So before we dive straight in, let's just talk about a few things. If you think about machine learning, the two big things that you need are data and you need machines. So let's start looking at how we can set up our data sets that we want to look at, and how do we actually set up the machinery that we want to look at. So over here in the manage is where your compute sits. There's a few different options of what you can use as a computing power. And it's one of those things where it fits every possible need, which again goes back to the idea of Azure Machine Learning Studio is kind of built for all different skill levels. So an instance is essentially a laptop server or a compute server that's sitting in their warehouses that you will borrow at any given time, and it can be used for notebooks, it can be used for creating some of the automated ML pipelines, all these different things. The difference between an instance and a cluster, essentially a cluster is multiple different compute instances working together. And this is kind of really handy when you're doing really big power loads, data loads and stuff to push together. And you need parallelization, where you need the kind of model to be running through multiple different data sets at the same time. So if you've got really, really big data sets, it can handle that, no problem. And you can choose how big or small you want your computing power to be. And the instance and cluster setup is essentially exactly the same. You pick a name, you pick your location, which you actually don't get to choose. Once you've created a workspace, it will be within that location itself. What kind of a machine do you want? You need to go through and figure out exactly what your use case is and see how much of a computing power you need behind it. And then you get to go pick from a bunch of different ones. These are kind of the ones that they've recommended, or you can actually select from all options. And there are then like thousands, like not maybe not thousands, maybe I'm being extra, but there's a lot of different options that you can go choose from. So this is for an instance, so one instance of it. The difference between an instance and cluster, again, as I mentioned, it'll be multiple different nodes of the same one that are joined together for you to use. So you can, again, create the same thing and you pick whichever one you'd like. The only difference here is you then obviously need to decide how many of those cluster computes do you want to cluster into one. A big shout out, make sure your minimum number is always 0. What that means is if you're not using it, it'll scale down on its own to 0 and not charge you for unnecessary numbers. But the other end of it is if you kind of always need the model running or anything, if that's a use case you need, feel free to run those up as much as you'd like. Just be aware of costing and things like that. You can go as high as you'd like in terms of the maximum number of nodes. So if you've got a really big data set, like you can go from like, I don't know, 10 or whatever, as many as you like. I think I've got a limitations of at the moment of 5 on the subscription I'm on, just so that I don't randomly rack up big charges. And you can also put in a timer. So if you haven't been using it for a certain amount of time, your compute power will just shut down for then and not charge you essentially. So loads of aspects there, which are really, really important to managing costs as you go through some of these solutions. And that's kind of it as well. You just pick and choose and you tell them essentially what you need. It is fairly user-friendly in that context of it tells you exactly what you will need. And don't forget, like if you do, but don't worry about the fact that if you do forget at this stage to create a compute, as you start using the product, it will tell you exactly what it needs at any given stage. So it's not too big of a worry at all there. Inference clusters can also be created. These are definitely a lot more expensive to run. And they're usually on the Kubernetes service. And this is essentially for, you've created a model, you need to deploy it somewhere, and you need to be able to like test it constantly back and forth. So all that can be done once you create one. I can show you exactly what it looks like. It's essentially the same as the other two. You can pick, let's say Australia East. And again, it's the same thing if you pick your cluster, the Kubernetes service that you want to select. All of it kind of goes back to what is your use case. And these are some of the things that you might want to think about before you jump into it. So we've got our computing thing down. The next big thing we might want to look at is data. So there's different options here. Let's look at our data sets first. if I want to create a data set, this is usually where I would do it. And you can also actually connect up any data that's already sitting within Azure. So if you go into data stores, you can actually create a new data store. And this is where you can connect anything else that sits within your subscription or something you have access to. So this is the Key Vault using it. And it's really, really straightforward in terms of if you've got access to it already, it'll just pop itself up and you can connect it through. And it's pretty secure in the way it sets these things up. I will leave that one for today just because I will be using a very quick demo to show you exactly how it works. So if I wanted to create a data set, and it's just a small CSV file, because if you're using a zero code solution, it might be the case that, hey, you just kind of have data, it's not too big, I want to see what I can do with it. This is probably going to be the way you'll be testing it out. So let's call this data set this Reactor demo. And this is where I can browse different files on my laptop. And so I've just got a file here, which is called CSV, It is a CSV for the Airbnb data. And I'm going to hit next. And it's just going to start the upload. Really hoping the Wi-Fi doesn't drop out now as it starts to upload this data set. But there we go. It's starting to pull that through. And basically what you'll start seeing now in a second, once it's actually understood what's happening behind the scene, it gives you a quick preview of exactly what your data set looks like. So this is a handy way for me to show you exactly the data we'll be dealing with. So we've got an ID number, the host ID, what neighborhood is it in over in New York, in terms of the 5 boroughs, and then specifically within that, exactly what suburb it's sitting in. What kind of a room is it? What was the price for that room? How many nights is the minimum you can stay? Number of reviews, and what's the availability of it per year? So is it kind of someone's family house or is it just specific Airbnb? And you can start messing around with different ways of looking at this data. Once you've got uploaded your data, another thing I want to just point out is it's actually pretty cool in terms of the way it understands and interprets the schema of your data set. So over here, you can actually choose. So if you've got a really big data set and you kind of only want to run a model on like 5 of those columns within it, you can actually choose within here. You don't have to go create different versions of that data set. You can just unselect some of the ones that you don't want to import into this data. And it also will identify automatically what kind of a data type it is. I don't think I've ever seen this get it wrong, but if it has misunderstood some of the data that you've uploaded, where it should have been kind of, I don't know, text, but it's picked it up as words, as numbers, you can go change that over here as well. So you've got your schema confirmed. You're like, yep, this looks right. Maybe I don't want specific columns. I will take those ones out. Maybe I don't want host ID. I can take that out here. And I'll hit next. And this is where you can confirm your data set, your details. Just make sure, yep, this looks right. This is exactly what I'm reading in. And you can hit create. Again, I won't actually hit create because I've already created some of these for you. So that Airbnb data set, let's have a quick exploration of it. So we can see here in another format of how it will look. So this is what the data set looks like. And now immediately this looks a little bit different to the one I just showed you in terms of uploading. And that's because you can actually create different versions of the same data set as you progress through them. So over here is the first version that I uploaded. And this will be the one that was like, I don't know, the 10 or 11 different columns that I was just showing you a second ago. So this had the host IDs and the neighborhoods and the reviews and so on and so forth, like multiple different ones. And as I start testing them, and I'm like, oh, actually, maybe I don't need this specific column in my data set. Let's just try a different version. You can just go through again and re-upload the same data set with different variances across it. You can have multiple versions over here. So it's a really easy way to keep everything collated in one place rather than having everyone running back and forth with multiple different variations of the same data set that exist kind of in this list, which you'll see some of them do exist here, but that was just me testing different things out. So we've got data, we've got our compute set up. Let's just actually get it going. Let's see how an automated ML would run. So I'm in here, and I think I said 4 clicks altogether to get an automated machine learning going. So let's see if that's actually true. So my data set is going to be the Airbnb one. You can again, and this is kind of where I was saying, it will kind of guide you to doing things if you haven't already done them kind of in pre-processing. So if you hadn't already uploaded a data set, it'll go through and allows you to do that directly from the service itself. So I'll pick that, I'll click next. So I'm going to count that as one click, right? I've picked my data set. I won't count the next as button clicks. But here I need to just name things. So again, like I said in resource groups at the start of the portal, an experiment is essentially just containing everything under one umbrella. So if you try and do different things against it, any model runs or different things that you keep trying out, at least it keeps it under one umbrella so you can kind of compare different solutions. So I'll call it Airbnb I've got one existing, so I'll just put it against it. What's your target column? So what do you want to predict on, basically? What are you trying to do? So I'm going to try and predict the price. And you need a compute type. So it tells you can actually use whichever one. Cluster will be a bit faster because it's got more compute. If you've got a lot of data, if you only need an instance, that's more than enough too. And what I want to point out here is if you don't already have one created, you can create one from here as a new one. And so again, you don't have to necessarily make sure you remember all these things beforehand. You can do them within the process of actually getting the one set up. So I've got one created. I'll just use that one for now. And this is the last bit where it's essentially telling it what kind of a task are you trying to do. So when you think about machine learning, and if you've no experience with it, don't worry about it. It does explain it pretty well. The three main types that it supports at the moment are classification. So if you've got data and you need to put it into two buckets, is this above 5,000 pricing or less than 5,000 pricing for a hotel room? That's called classification. It's just segregating your data. It's one or the other. Regression is where I want to predict a specific number. So based on the hotel room or the Airbnb room, where is it? How many nights can people stay? What's the availability? I want to predict an actual number, which is going to be the price for that place. So what I want to do is regression. You can also, again, from here, essentially tell it exactly what kind of a metric you want to use. Maybe you want to use different ones. There's a bunch of different options here for you. And I think Sarah will be attaching links in terms of just the Microsoft Docs. If she doesn't, honestly, it's just the original Microsoft Docs, which explain every little bit of the whole thing, right? All these words, what do they mean? They will go through all of them to have a read through, whichever you're looking to do. And you can also do featureization. So if you don't want a specific thing to be a feature, you can select that. If you don't have value, if you like, there's values missing, how does it deal with that? You can explain everything to it, or you can leave it all to itself. Like you just give it your data and you're like, go figure it out. I don't care how you do it, just do it. And that's essentially it. So I won't tell it to do anything else. You can add this optional step in, but if you didn't want to, you just hit finish and it starts training it. So I think that was like 3 main clicks in terms of you select your data, you configure it, attaching it to your current compute powers, and then you tell it what you want it to do. So maybe not exactly 3, but like 3 overall things that you had to do to get it going. So I'm going to cancel this to show you one that's already been created. So I said we'll put it under Airbnb as a, what's it called? An experiment. So this was the experiment that it ran. And what it tells me is the best model that it found was voting ensemble. And we can have a look like, okay, great. Why did you find this one? Actually, let's go back to why did it find this one? So these are all the different runs it did. Let's have a look at the different models it ran. So what you'll see is what it's kind of done. It's taken your data and it's running against multiple different algorithms that you can see over here and mix and matching them and giving them a shot. And what the kind of primary metric to get the best output for was a normalized root mean square error. And as you can see, the best one was voting ensemble. So it's kind of come back and it said, this is the best model I found for your requirements that you've asked me to find. And then you can actually have a look at the explanation of, okay, why? Why did you think this? What did you find? What are the details? So you can start playing around with this a little bit in terms of, okay, so it tells you what were the most important features. I'm just going to move this up a bit so you can see a bit better. And you can choose kind of how many you want to see out of all the different ones you have. So I can see in like, okay, the last 3 are really not having too much of an impact compared to the first few. As expected, the room type is probably going to have the most kind of importance on the price. And then where is it sitting? Probably the next one up. So what you can kind of then do is, okay, maybe I'll rerun this model by taking out some of these extra columns and see how I go. And you can start doing that. And this is where you can version your data set, create a new version of it, rerun the model again, and see how you go. So I did that, and let's see how it went. So experiments. So I dropped some columns, and then I wanted to see how it did this time. So this was the run. It took about 20, 30 minutes, I think. Yeah, so 30 minutes is how long it took to run this. And that means it's gone through and tested against all these different models in the background. And you can see the individual models, it takes about a minute or less against them to actually run them. So the time overall is just the fact that it's running them through multiple different, like 30, 40 different models or algorithms in the background. So this one, when I've dropped a few columns, this was the new metrics that I found. And kind of when I think I did this again, where I looked at all the different variances and I'm like, okay, maybe I really don't need these ones. We can get rid of some more. And this is where kind of AutoML can be helpful in terms of testing different parts of it out. And you're like, oh, do I really need this? I don't know. Maybe let's give it another shot. So there's loads of different parts of it that are attached. You can start explaining different things. So as much of it is a black box in terms of you're giving it data and you're getting an answer back. You don't know what's happening in the middle. They are working on kind of helping you understand why it came to these different options and what kind of happened in the background. You can also actually see exactly what processing it did before it started kind of hitting your data against those algorithms. So you can see some of them, the data sources were turned into categoricals, numeric, categoricals, like all these different things are happening. And it does actually explain how it did those and what it was doing in the background. So I hope that kind of like made a little bit of sense. And once you've kind of created a model, you can actually go into the details, look through them if you'd want to. But this is my model. And from here, you can actually deploy this model, whether it's to a web service or a real-time endpoint. And what does that look like? Ooh. So if I've deployed that model to an endpoint like this one, this is kind of what it comes out to, and it gives you a REST endpoint. And I am no software developer, so I've never really attached them myself, to be honest, but I have had friends who've tried to do this where they are software developers, not necessarily data scientists, who've popped their data in here, got an endpoint, and then attached it into their app where they can query, kind of they put their numbers in, and then they shoot it against the endpoint. So the model runs and gives them back a prediction at the other end of it. So we've used absolutely no code up until now. Maybe you will be needing to when you attach it to an application moving forward. But to create that whole aspect of it was all zero code involved. So that is how you would use automated ML. I hope it is going okay and people are understanding and they're still with me at this stage. So with that, let's dive into what a designer pipeline would look like. I was going to create a new one. I think we've got a little bit of time. Actually, maybe I'll just run through one I've already created just to save a bit of time, and we can save time for questions. Sarah, I think you're popping in. Is there questions?
Yes, we did have one question come through from Jim. So he said, can I generate a notebook of final model?
A lot of the actual data, okay, that's a good question. I haven't actually fully tried that myself, but what you did see a second ago was, sorry, let me just go into the experiment again, and you can actually see that was something that they're working on in preview, because that was the first time I'd seen it myself. Where you could see different parts of it in the actual, oh, no, you can't actually. Sorry, I take that back. I thought you could. No, look, it is a black box, and this is the protected IP part of it that comes into from Microsoft's point of view. They've created all these different algorithms in the background, and if they kind of open those up, then there isn't really a point to the system and the platform a little bit. So that's protected IP, and we do understand why that kind of plays into it. But what I would say is if you did want to use, so automated ML is also an SDK that you can use as a Python notebook. And you can actually use those. I've done kind of other sample demos and stuff. If you want to reach out afterwards, I can run you through that if you'd like. But essentially, it's just coding through automated ML to help quicken out the pipelines and stuff. And you can kind of pull those models back in once they've been created to keep using as in the notebook environment. But you don't get to see the actual kind of coding behind each of these algorithms, if that makes sense. And I hope I answered your question. It was a little bit rambly. But I will check in at the end of the designer bit to make sure that that kind of made sense. Okay, so sorry, I would create one, but I feel like there's a few questions, so we can jump into questions after this. So I'll just open up one that I've already created. So just as a quick one, there's sample data sets available, and that's where I've pulled in the automobile price data. So this is for the secondhand cars. So this data set, let me show you what this data set looks like. Sorry, I feel like it used to be, maybe I could get it a bit bigger, but just as a quick highlight of the different columns that it does contain. So what make was the car? So you can see a lot of Audis and Alfa Romeos. What's the fuel type? What's the number of doors the car has? What kind of a body does the car have? A lot of individual details. Some of them I don't even know what they mean because I'm not that big of a car buff. And that's the point. Like, this model should tell me what a fair value of a car is based on these different features that I don't necessarily need to understand the differences apart from. But yeah, so look, this is the price of a car that was put in with all these different features is what that data set is. And what Designer will then let you do is based on that data set, it's a full data set, you can start picking and choosing exactly what you want. So you can select your columns in this data set. So you can edit the columns. Maybe I want to include all of them and then just exclude one column, or you can kind of pick and choose exactly how many. So maybe let's do another one. If you don't want to include all of them, you can actually include specific by column names. You can choose exactly which ones you'd like, and so on and so forth. So maybe you've tried this before and the model came back with actually you only really needed like 5 or 6 of the features to really make an impact on this model. You can go back and do that and edit those different parts of it out. Another big problem in machine learning environments is how do you clean your data? So this is kind of where that designer part of it sits exactly in the middle of absolutely no machine learning background or coding background, but also having some experience with like, how do you work with this in terms of a machine learning pipeline? So you need to have your features and then you need to clean the features, which again, you can do. And there's different variations of how do you clean. You can custom substitute values, replace them with mean or impute different variations of them. So it does give you quite a few different options. Once you've cleaned your data, you usually just split your data into a training and testing set. And again, you can actually choose exactly how much of the percentage split you want to do. So for this example, I just used 70%. And if you want it randomized, exactly what seed you want, all the different kind of usual nuances you'd be used to doing in a notebook environment. Just made a little bit easier where you're not having to type out the Python parts of it and just dragging and dropping it in. And this, again, it kind of goes back to having a bit of that machine learning experience of knowing what kind of a algorithm you want to run. So over on the left is where you can find all these different parts of it. So there's about 19 different algorithms that they have that you can use from these. So you have a look, you can kind of go through which specific one you need for that use case. And it kind of has a little bit of explanations to them as well. So for this one, we just used a very quick linear regression model, and then you need to train it. So you've got your linear regression, it pulls into it. That's the model I want to train. And this is the data I want to train on. So you can see here, this is the result data set one. So this will be the 70% of the data. And then the 30%, which is the second part of it, will go into the next part. So I'm going to train my model, the data that I have, 70% of it, and I'm going to use a linear regression model to do that. So training and testing essentially is just like being back in school. You spend 9 months of the year training by like learning different things in school. And then at the end of it, there's a test where you actually get to have a test on all the unseen things that you've learned over the year. So majority of the work that it goes into is just training that part of it up. Once it's understood it, we have saved some data it's never seen before, and then we'll just test how well it learned based on that pre-existing data. So that's what this part is, scoring the model. It's like, okay, cool. Now you've done that, score against it. This is a model. Look at this new data. How well did it do is the evaluation part of, okay, great. You've now learned. What did you do with this? How did you go? So this was how long it took, was about 49 seconds for this step. You can actually go through and check all these different parts of it, exactly what it was doing, have a quick look at it if you would like. So the metrics that I found out was the coefficient of determination was 0.86868, which from kind of a big, huge data set with like features that probably didn't make a big impact at the end of the day was being thrown into it too. It's pretty good for a first try. So from here, you can obviously go back and kind of start messing around with your data, taking certain bits out, try a different model, try different algorithms. And you can do that at multiple different ones as you're running them and as you go. So as you can see, again, so no coding was needed to create this. This was just dragging and drop that you can pull through different variations. What I will point out is actually the fact that you can still code if you wanted to. If you had something really niche or specific you wanted to do, you can just build in specific scripts from Python or R within those to like kind of augment the drag and drop UI if you have a really specific use, which isn't already being covered by some of the different drag and drop models. So once you've created it, this creates a model, which you can, again, same kind of pipeline as the past one, where you can deploy your model into an endpoint, which, let me show you what that would look like, is exactly the same as the other one. So there's another REST endpoint that you can kind of start hitting up and attach it to whatever use case that you might have for a low-code solution. So what this is essentially doing is if you've already got things that work and you want to augment a little bit of AI into it without too much of an effort, these are a great starting point. It's also a great starting point if you are kind of trying out different variations of things and wanting to see if a specific model might be the right answer as you go through them. It's a handy point for doing those kind of aspects as well, for training and testing things out before you go kind of put a lot of work behind creating a specific model. This is a good, quick way of testing out smaller ones. And you're like, okay, this might be the right path to take, and I can go do that and create more bespoke stuff from there. So overall, that is essentially how it works. I'm going to jump back into the slide deck. I hope so the agenda for today, look, was to kind of show you how to create zero code solutions and like models. I hope I did that. I hope that made sense. That you could see that, hey, if you wanted to jump in and create them yourself, you can. And also how kind of one platform houses kind of everyone essentially, whether you have that background in coding or machine learning or neither, it does kind of cater to all the different parts of it and different needs. So I hope I kind of made that point come across fairly quickly. If you do end up trying this out for yourself, which makes me really happy if you do, because it makes me feel great. I'm like, oh, people did actually find this useful. Reach out to me on kind of socials or wherever you might find me. I'm kind of all around the place. Twitter is probably the easiest place. Reach out, let me know how you went. And if this is something you want to try and implement yourself as a business that we can try and help out with, reach out to me in a professional capacity. We're more than happy to have those conversations and see if we can help, because we're currently working on a lot of different projects around this area. So I guess, thank you for listening. If you have any questions, I'm sure Sarah's been keeping track with them.
Thanks, Akanksha. Yeah, we did have one question come through from Cooper, but just before that one, just to mention those links, those Microsoft Docs that you said, I don't actually have the links for those. So if you could post them now in the private chat, that would be great. So then I can share that with everyone now in the comments section before we finish up for today. So whilst you're getting those links and putting them into the chat for me to copy across, we did have a question come through from Cooper K. So he said, has anyone tried running these ML models against app insight exceptions? For example, to see trends of old new errors by multiple / single applications impacted.
I think it dropped out because I was trying to do too much at the same time, like copying things. So I hope you can hear me.
Okay. Doing two things at once. I've just put that up on the screen.
That's okay. That's perfect. Honestly, Cooper, I haven't had a look at that, so I don't have an answer for you, but I can have a look and get back to you if that's a little bit easier. But yeah, I honestly do not have an answer for that question. Sorry.
Okay, no worries. Well, people can find you on your, if we want to get that slide back up again, just on your, I think, was that your LinkedIn or your Twitter handle for people to be able to contact you? Are you having trouble hearing me? I think we're having some technical difficulties and we're dropping out a little bit, which is okay. We managed to get all the way through the presentation, which is the main thing. What I will do now is, that was our final question. So what I'm going to do is just put into the comment section a link again to our YouTube channel. So if anyone wants to reference back today's demo, you can do so via that link there. And we'll also put in a link to our feedback survey. So please do take the time to fill that out with the event code, which I'm just putting in there now as well. So it's 15483. Your feedback helps us to curate our future topics and make any amendments. So that would be super helpful if you took the time to fill that out. And also I'll put in a link to our current meetup page for Sydney. So we have all of our great, exciting upcoming events for March and April. So do check them out. Some great topics coming up. And so you can register for that for anything in the future. Thank you so much, Akanksha, for coming here today and presenting. Even though we had a couple of technical difficulties at the beginning, we got there in the end, and the demo went very smoothly. So everyone will be able to reference that back, and which is great. And then you can review that on our YouTube channel. So that will live on the Reactor YouTube channel. Anybody to reference back at any point. So thank you. Have a good rest of your afternoon, evening, or morning, and we will see you next time for another Microsoft Reactor live stream event. Thanks,
Perfect. Thank you for having me.
Thanks for coming. Bye.